Hello students. First of all, let me apologize for not being able to open my laptop's camera. It is not working today and I do not know the reason. But let us start with our today's session. We are solving the IB Math EA HL past papers. And from today, we start to solve the IB Math EA HL November 2022 paper 3 past paper. Today, we'll be solving the question number 1 of this paper. And in our coming session, we'll be solving the question number 2 of the same paper. And most probably, I'll not be able to open the camera in our next session also because I'll be recording these two questions together. Okay. And you will be getting the links to all the previously solved questions of the other papers in form of playlists in my channel, NS Online Math Tutoring Classes. So without any further delay, let us start answering question number 1. The maximum mark is 28. In this question, you will investigate series of the form sigma I equal to 1 to n, I raised to the power of q, which is equal to 1 to the power of q plus 2 to the power of q plus 3 to the power of q plus dot 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 plus n to the power of q, where n and q belong to the set of positive integers, and use various methods to find polynomials in terms of n for such series. Now, first of all, we consider the case when q is equal to 1. The above series is arithmetic, and the first question, that means the subpart of question 1, subpart A says, show that sigma I equal to 1 to n I equal to half times n plus 1. It is containing just a single mark. But why are they saying that the above series is arithmetic when q is equal to 1? Let us first of all check that. Okay, so I equal to 1 to n, I to the power of q is equal to I equal to 1 to n, I to the power of 1 when q is equal to 1. Okay. I to the power of 1 is I. So this is I equal to 1 to n, I. When I is equal to 1, it will be 1. And sigma means summation. When I is equal to 2, it is 2 plus 2. I is equal to 3 plus 3. And so on. The last value of I is n. So it will be plus n. So this is an arithmetic series definitely, because the first term u1 is equal to 1. The common difference is equal to 1. And number of terms is equal to n. Also, the last term is also equal to n. You may use the last term or you may use the number of terms. Let me use the last term. Last term equal to n. Okay. So now we will be using the formula Sn, which is the sum total of the first n terms of an arithmetic series. So this will be equal to, there are n number of terms. So n over 2, first term equal to 1 and the last term equal to n. So this is equal to half times n times n plus 1. Okay. And what is Sn? Sn is 1 plus, this is, Sn is 1 plus 2 plus 3 plus dot 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 plus n, the sum total of the first n terms. This can be written in sigma notation form as I equal to 1 to n, I, and this should be equal to Sn equal to half times n plus 1. Okay. So this is the proof of this. It is shown. Okay. Consider the case when q is equal to 2. The following table gives the values of n square, and this is sigma I equal to 1 to n I square, because q is equal to 2. It was ith power of q, so it is I square. For n equal to 1, 2, 3. So these are the values of n. These are the values of n square. 1 square is 1, 2 square is 4, 3 square is 9. And these are the values of sigma I from 1 to n I square. How are we getting these values? It is sigma I equal to n is equal to 1. So it is 1 to 1 I square. Okay? I equal to 1. So it is 1 square. Since I is ranging between 1 to 1, we will be having only a single term. So this is equal to 1. Okay? Next one, it is n equal to 2. So I equal to 1 to 2 I square, which is equal to, first value of I is 1, so it is 1 square and sigma summation. Now the second value of I is 2, 2 square. 1 square is 1, 2 square is 4, 1 plus 4 is 5. Okay, so you can get this value of 5 by adding this 1 to this 4. You get 5. Okay, coming to this third row, and over here we are having the unknown P. Subpart B's first subpart I says write down the value of P. It is containing just a single mark. Now the value of n is 3. So I equal to 1 to 3 I square. First value of I is 1. So 1 square. Second value of I is 2. Sigma, so summation. Third value of I is 3. So it is 1 square plus 2 square plus 3 square. 1 square is 1 plus 2 square is 4. 1 plus 4 is 5. 3 square is 9. So 5 plus 9 is 14. You can add 5 and 9. The P value will be 14. Okay. The II. Sum of the first n square numbers can be expressed as a cubic polynomial with 3 terms. And these are the things. This is the equation given. Sigma I equal to 1 to n I square is equal to a1n plus a2n square plus a3n cube, where a1, a2 and a3 belong to the set of positive rational numbers. Hence, write down a system of three linear equations in a1, a2 and a3 containing 3 marks. Okay, I can write the answer over here. Fine. When n equal to 1, because n's value is equal to 1, 2 and 3. First of all, I'm starting with n equal to 1. So, I equal to 1 to 1, I square is equal to 1 square equal to 1 equal to a1 times 1, n's value is 1, plus a2 times 1 square plus a3 times 1 cube. Therefore, a1 times 1 is a1, a2 times 1 square is a2, a3 times 1 cube is a3, is equal to 1. Okay. Next one, n equal to 2. So, sigma I equal to 1 to 2, I square is equal to 1 square plus 2 square, which is equal to 5. Now, n value is equal to 2. So, this is 8, 1 times 2 plus a2 times n square, that is 2 square, plus a3 times n cube, that is 2 cube. So 2a1 plus 2 square is 4, so plus 4a2 plus 2 cube is 8 plus 8a3 is equal to 5. This is the second equation. This is 1, this is 2. And the third one is when I is equal to, n is equal to 3. So, and I square. So this is 1 square plus 2 square plus 3 square, which was equal to 14. P. So this is equal to 14 is equal to A1 times n equal to 3 times 3 plus A2 times 3 square plus A3 times 3 cube. Okay. So 3a1 plus 9a2 plus 27a3 is equal to 14. This is the third equation. Okay. They have asked us to give a system of 3 linear equations. These are the 3 linear equations. Fine. Hence, the third subpart, hence find the values of A1, A2 and A3. This is paper 3. So we can of course use the calculator. But before that, I cannot enter A1, A2, A3 in calculator. So let us assume let A1 be equal to X, A2 be equal to Y, and A3 be equal to Z. Okay. So the equations become X plus Y plus Z is equal to 1, 2x plus 4y plus 8z equal to 5, and 3x plus 9y plus 27z equal to 14. And we will be using the calculator. I am using the TI Inspire CX2 calculator to get the values of x, y, and z. Okay. So we have to solve a system of simultaneous equations. Therefore, we are on the calculator page. So we press menu and then algebra. And then we have to solve a system of linear equations. So it is number 2. How many equations are we having? 3 equations. And you can write the third variable as z. You may leave it. The calculator will be taking the third variable as z. We press OK. Okay, see, the calculator has taken the third variable as z. Okay, you instead of xyz, you can take the variables as abc or any other variable, but you cannot have the subscripts that as a1, a2, and a3. Okay, that is why I have changed the variables. So first equation is x plus y plus z equal to 1. So x plus y plus z equals 1. And then I can come down and 2x plus 4y, 2x plus 4y plus 8z equal to 5. Come down 3x plus 9y plus 27z equal to 14. And I come out of the parenthesis and I press enter. Let me press control enter because I was doubtful about whether the answers will be in decimals or will be integer values. And we are seeing the answers are in decimal numbers. This one, you may be knowing 0.5 is half and 0.3333, it is recurring, it is 1 over 3. But even if you give them up to 3 significant figures, the answers will be taken as correct. Okay. You may give the exact value, this in place of 0.5, 0.5 is the exact value. So y, you can write it as 0.5, or you can write the y value or E2 value as half or 0.5. You can write the E3 value as 0.333 up to 3 significant figures, or you can write E3 value as 1 over 3. This one, 0.1 and 6 recurring, is the decimal equivalent of 1 over 6. And in case you do not know, doesn't matter, even if you write A1 value as 0.16 and 7, it will be correct. Let me just show you that the 1 over 6, when converted to decimal, is indeed equal to that, this one, this number. Okay? Or else you can just, I have pressed the control enter. In case it is not working for you, I'm just copy pasting this, and then I can use the numbers and convert to decimals, enter. See, you are getting the same value. Okay. So let us write A1 as 1 over 6 and A2 as half and A3 as 1 over 3. Okay. So A1 using calculator or using GDC, A1 is equal to 1 over 6, A2 is equal to half, and A3 is equal to 1 over 3. Okay. Again, I'm showing you A1 is equal to 1 over 6, A2 is equal to half, and A3 equal to 1 over 3. Okay. Moving on to subpart C. You will now consider a method that can be generalized for all values of Q. Consider the function f of x equal to 1 plus x squared plus dot 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 plus x to the power of n, where n belongs to the set of positive integers. Subpart C, show that x times f dash of x, that means the first derivative of f of x, equal to x plus 2x squared plus 3x cubed plus dot 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 plus n x to the power of n containing just a single mark. Okay. So this one, f of x, we have to differentiate the f of x expression. So f dash x is equal to derivative of 1 will be 0, derivative of x is 1, derivative of x squared is 2x, plus it should be, the third term should be x cubed. So it will be 3x squared plus dot 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 plus n times x to the power of n minus 1. And then we have to multiply this entire expression by x. Therefore, x times f dash x is equal to x plus 2x squared. X times 1 is x, 2x times x is 2x squared plus 3x squared times x is 3x cubed plus dot 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 plus n times x to the power of n minus 1 times x is x to the power of n. Okay, shown. Let f1 of x be equal to x times f dash of x, that means the first derivative of f of x, and consider the following family of functions: f2 of x equal to x times f1 dash of x, f3 of x equal to x times f2 dash of x, f4 of x equal to x times f3 dash of x, and dot dot dot, fq of x equal to x times fq minus 1 dash of x, that means the q minus 1th derivative of f of x times x. And it is saying f1 of x equal to x times f dash x. And x times f dash x is having this expression. This we had proved in our previous subpart. So this is equal to f1. Okay. Now coming to subpart D's question, it is having three further subparts. I is show that if 2 of x equal to sigma I equal to 1 to n I square x to the power of I. Okay. So I, if 2 of x should be equal to x times f1 dash of x. And f1 dash of x is this, f1 of x is this. So we have to differentiate this. So this is x times derivative of x is 1. Derivative of 2x squared is 2 times 2 is 4, so it is 4x. Derivative of 3x cubed is 3 times 3 is 9x squared. And so on. This will be the last term, n times n, that is n squared, and x raised to the power of n minus 1. These terms, when multiplied with x, will be giving us 1 times x plus 4 times x squared plus 9 times x cubed plus plus n times x to the power of n minus 1 times x is x to the power of n. Okay. So if 2 of x is this, and this can be written as this one is 1 squared, 4 is 2 squared, 9 is, this is n squared, 9 is 3 squared. So whatever is the power of x, that squared is the coefficient of the term. Whatever is the power of x, when the power of x is 1, 1 squared is the coefficient. When the power of x is 2, 2 squared is the coefficient. When the power of x is 3, the 3 squared is the coefficient. When the power of x is n squared is the coefficient. Okay. So therefore, in sigma notation, it is summation. So we can use the sigma notation to represent the series. It is, and there are n terms. So it is I equal to 1 to n. I square, when for the first term I is equal to 1. So I square, second term I equal to 2. I square, third term I equal to 3. I square. So it is I square and x raised to the power of I. Okay. So this is the expression that they had asked us to show. Shown. Okay. And now coming to the II part, the mathematical induction. Okay, fine. Mathematical induction. Prove by mathematical induction if q of x is equal to summation sigma I equal to 1 to n I to the power of q x to the power of I, where q belongs to the set of positive integer. It is containing 6 marks. Okay. So we can write when q is equal to 1, if 1 of x is equal to, f1 of x is this, x plus 2x squared plus 3x cubed plus plus nx to the power of n, which in sigma notation can be written as this is 1, x to the power of 1. I equal to 1 to the power of 1 to n, I and x to the power of I. And q is 1, so I can write I to the power of q and x to the power of I. Okay. Or first of all, you can write I to the power of 1, x to the power of I, and then you can write I to the power of q and x to the power of I, because q is 1. Okay. So true when q is equal to 1. Okay, q is any positive integer. Let the relation be true for q equal to k. K belongs to the set of positive integers. Okay, therefore, if k, in place of q, we are writing k. If k of x should be equal to sigma I equal to 1 to n I to the power of k and x to the power of I. Okay, let this relation be true for q equal to k. So this is true. To prove if k plus 1x is equal to I equal to 1 to n and I raised to the power of k plus 1 because q is equal to k plus 1 now. X to the power of I. That means q is equal to k plus 1 is true. Okay. So if k plus 1 will be what? It will be x times if k dash of x. Okay. So first of all, let us write what is fk of x. Fk of x is equal to 1 to the power of anything is 1. First value of I is 1. So, okay, let me write 1 to the power of k, x to the power of 1 plus 2 to the power of k, x to the power of 2 plus 3 to the power of k, x to the power of 3 plus dot dot dot. It will be I is equal to n plus n to the power of k, x to the power of I is n. So, n. Okay. Therefore, x times if dash k of x should be equal to x times this 1 to the power of k is 1 and x is x. So it is x. Derivative of x is 1. This is x squared. Derivative of x squared is 2x. We are having to the power of k times 2, which will be 2 to the power of k plus 1 x plus 3 to the power 3 comes down. So it was 3 to the power of k times by 3 is 3 to the power of k plus 1 x squared and dot 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 plus n comes down, n to the power of k was there times n is n to the power of k plus 1 and x to the power of n minus 1. This when multiplied by x will be giving us x plus 2 to the power of k plus 1 x squared plus 3 to the power of k plus 1 x cube plus dot 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 plus n to the power of k plus 1 x to the power of n. Okay. This can be written as 1 to the power of k plus 1 also and x to the power of 1. So this is equal to, therefore this is equal to x times if k dash of x is if k plus 1 of x. And this when written, this part when written in sigma notation form will be I equal to 1 to n. First value of I is 1, last value of I is n. I to the power of k plus 1. Over here, q is k plus 1. And x to the power of I. This is what we had to prove. I equal to 1 to n, I to the power of k plus 1 and x to the power of I. Okay. So, therefore, if k plus 1, if k plus 1 of x is true, whenever if k of x is true for all k belonging to the set of positive integers. Okay. So, by mathematical induction, what should I be doing? If q of x sigma I equal to 1 to n, I did not write fq of x first, so I'll be writing it later on. I to the power of q and x to the power of I to the power of q, x to the power of I, and q belongs to the set of positive integers equal to fq of x is true. Okay. And we are having the I subpart as well. Let me solve it over here. I don't have any space below. So, using sigma notation, write down an expression for fq of 1. This is fq of x. In place of x, we will be writing 1. So, therefore, this is I. Fq of 1 is equal to I equal to 1 to n, I to the power of q. So, I to the power of q and 1 to the power of, it's 1 to the power of I. Okay. So, this will be equal to, for the first case, i's value is 1. Therefore, it will be 1 to the power of q because 1 raised to the power of anything is 1. So, we are having just this part. 1 to the power of q plus 2 to the power of q plus 3 to the power of q plus dot plus n to the power of q. So, this is the answer. Okay, we have to in fact give the answer using sigma notation. So, this is just the expanded form. So, I have to just write this as equal to I equal to 1 to n I to the power of q. This will be the final answer of I because they are asking for the sigma notation. This is actually the answer in expanded form. Written in sigma notation, it is sigma I equal to 1 to n I to the power of q. Okay. Subpart E, by considering f of x equal to 1 plus x square plus dot plus x to the power of n as a geometric series for x not equal to 1, show that f of x equal to x to the power of n plus 1 minus 1 over x minus 1 containing 2 marks. Okay, fine. Let me start my answer over here. Okay, f of x, or I won't be getting space. Let me start over here. Okay. And this is a geometric series. So the first term is equal to 1. The common ratio is equal to x. And the number of terms What will be the number of terms? See, this is having x to the power of n. That doesn't mean that the number of terms is equal to n. You have to be careful about this because second term is having the power of x is as 1. The first term is 1, which is having the power of x as 0 because any number raised to the power of 0 is 1. So 1 can be written as x to the power of 0. Therefore, the number of terms present is n plus 1 and not n. You have to be careful about this, okay? N plus 1, okay? And now we have to use the formula for the first n terms of a geometric series. So this will be equal to u1 times r to the power of n, where n is the number of terms, minus 1 over r minus 1. Okay. So in our case, therefore, x n plus 1, because the number of terms is n plus 1, u1 is equal to 1 times r is equal to x. X to the power of number of terms is n plus 1 minus 1 over x minus 1. This should be equal to x to the power of n plus 1 minus 1 over x minus 1. And this is equal to f of x because we have added these terms using the formula and we have got this expression. So this is the expression. Shown. Subpart F, for x not equal to 1, show that f1 of x. What was f1 of x? It was x times f dash of x. Okay. So f1 of x is this. Therefore, f1 of x is equal to x times f dash of x equal to x times. We have to differentiate this expression. We will be using the quotient rule for this. Okay. X minus 1 whole square. First of all, the numerator gets differentiated. The derivative of minus 1 will be equal to 0. The derivative of x to the power of n plus 1 will be n plus 1 times x to the power of n plus 1 minus 1, which is n, and times by the denominator. So it is x minus 1. And then minus, now the denominator has to get differentiated. The derivative of x minus 1 is definitely equal to 1. And the numerator stays x to the power of n plus 1 minus 1. Okay. So this is equal to, therefore, this is equal to x times, I am just separating the terms. So n plus 1 x to the power of n times x is, because I am seeing the terms are separated. That is why I am just multiplying and expanding this numerator. The denominator is kept as x minus 1 whole square. I am not expanding the denominator, I am expanding the numerator. So n plus 1 times x to the power of n plus 1, x to the power of n times x is x to the power of n plus 1. And there is this minus 1. So x to the power of n times minus 1 is minus x to the power of n times n plus 1. So it is minus n plus 1 x to the power of n. And this one is minus x to the power of n plus 1. And minus of minus is plus, so it is plus 1. Over x minus 1 whole square So this is x times, I can take x to the power of n plus 1 common, and this is n plus 1, and this is minus 1. Minus n plus 1 x to the power of n plus 1 divided by x minus 1 whole square. Okay. And n plus 1 minus 1, these two will be getting cancelled. Now we can multiply. X times x to the power of n plus 1 is equal to, therefore, f1 of x is equal to x to the power of n plus 2, and this is n. So n times x to the power of n plus 2 minus n plus 1. X to the power of n times x is x to the power of n plus 1 plus x divided by x minus 1 whole square. See, n times x to the power of n plus 2 minus n plus 1 x to the power of n plus 1 plus x divided by x minus 1 whole square. Okay. Obviously, for x not equal to 1, because if x equal to 1, the denominator will be equal to 0. So x cannot have a value of 1 for x not equal to 1. Shown. Okay. Subpart G, the last subpart of this question is containing two further subparts. The I is saying show that limit extends to 1 if f1 of x is in indeterminate form. And we had found the expression for f1 of x as this in our last subpart. So we have to show that as x tends to 1, this is having an indeterminate form. So I limit x tends to 1 f1 of x is equal to limit x tends to 1 n times x to the power of n plus 2 minus n plus 1 x to the power of n plus 1 plus x over x minus 1 raised to the power of 2. This is equal to n times 1 to the power of n plus 2. I'm not writing the limit again because I am substituting 1 for x. The expression is having no more x, so I am not writing limit anymore. Minus n plus 1 times 1 to the power of n plus 1 plus 1 over 1 minus 1. So this is n minus n. This is 1, so I can expand this minus n and minus 1 plus 1 over 1 minus 1 whole square, which is equal to 0 over 0. Indeterminate form. Okay. Now coming to I. Hence, by applying, because it is an indeterminate form, if we have to find the value of f1 of x or expression for f1 of x, show that limit x tends to 1 f1 of x equal to half times n plus 1 containing 5 marks. Okay. So they have given the rule that we have to apply. And so what do? We have to, this is the f1 of x expression, which is 0 by 0. So we have to Differentiate the numerator and the denominator separately. Limit x tends to 1 d dx of n x to the power of n plus 2 minus n plus 1 x to the power of n plus 1 plus x over d dx of x minus 1 whole square, okay, is equal to limit x tends to 1. Derivative, what will be the derivative of the first term? It is n times n plus 2. And x raised to the power of n plus 2 minus 1 is n plus 1. This one, second one, n plus 1 comes down, so it is minus n plus 1 whole square. And x to the power of n plus 1 minus 1 is x to the power of n. And plus x, the derivative is plus 1. Over derivative of this is 2 times x to the power of, x minus 1. And the derivative of x minus 1 is 1. Okay. And now let us substitute 1 in the place of x and let us see what expression do we get. Equal to n square. Okay, let me write n square plus 2n. And 1 to the power of n plus 1 minus n square plus 2n plus 1. Since I have expanded this, I am expanding this one as well. 1 to the power of n plus 1. Okay. So equal to over 2 times 1 minus 1. Okay. So this is equal to n square plus 2n. And this one is times by 1 is nothing. It is just the same thing remains. So minus n square minus 2n minus 1 plus 1 over 2 times 1 minus 1. So this is again equal to 0 over 0. Indeterminate form. Okay. So again we have to differentiate. Let us take this expression and differentiate. So if limit x tends to 1, f1 of x is equal to d dx. This is also equal to limit x tends to 1, f1 of x is equal to this. D dx of limit x tends to 1, I have to write it over here also. D dx of n times n plus 2 and x to the power of n plus 1 minus n plus 1 whole square, x to the power of n plus 1 over d dx of 2 times x plus minus 1. Okay. So this is limit x tends to 1. Now we have to differentiate this. N plus 1 will be coming down, so it is n times n plus 1 times n plus 2. And in x to the power of n plus 1 minus 1 is x to the power of n. And now this n will be coming down, so it is minus n times n plus 1 whole square, x raised to the power of n minus 1, and the derivative of 1 is 0. And the derivative of 2 times x minus 1, 2 is the coefficient, derivative of x minus 1 is 1, so it is the denominator is just 2. So this time we are sure that we will not be getting an indeterminate form. The denominator is 2. Now let us substitute 1 in place of x. So n times n plus 1 times n plus 2 times 1 raised to the power of n minus n times n plus 1 whole square, 1 raised to the power of n minus 1 over 2 is equal to 1 to the power of n or 1 to the power of n minus 1. They don't contribute anything. I can take n plus 1 common from these two terms. So n plus 1, and this is n times n plus 2, which is n square plus 2n. Okay. And from this term, it is 1 n plus 1 has been taken out, and n times n plus 1 is remaining, which is n squared plus n, and there is the minus sign outside, so it is minus n squared minus n over 2, which is equal to n square and n square, they cancel, 2n minus n is n. So this is equal to half times n plus 1. Okay. So therefore, limit x tends to 1, f1 of x is equal to this. Okay. Show that, so we have shown. So this brings us to the end of this question. We are having the second question remaining. We will be solving that in our next session. Thank you for watching. Thank you for staying with me till the end. In case you have liked my explanation, please to give this video a like, and please to share this video with your friends so that even they can get benefited by watching this video. And please to subscribe to my channel. In case you have not subscribed to me till now, please subscribe to my channel. It will be motivating me to make more math videos for you. I'm Nilanjana Sanyal. I am an online IB Math A, SL and HL level tutor. I offer both one-on-one and small group online tutoring services to my students. So we meet again very soon in our next session. Till then, bye.